Hello and welcome to this video that goes through the AQA Level 2 Further Maths GCSE Specimen 2 paper. In this video we're going to go through questions 16 to 19. So if we look at question 16, is work out the equation of the perpendicular bisector of P, which is 3 minus 1, and Q, which is 5, 7. Give your answer in the form y equals ax plus b. So the first thing we need to pull out here is some key parts of this question. So the first thing here is the perpendicular. So that means that the gradient will equal to minus 1 over, we'll call m1, where m1 is the gradient between PQ. So that tells you that if you had the line, for example, that you're going to have your perpendicular one is going to be 90 degrees, or is going to be the negative reciprocal of the original line. And then the second thing is the bisector. So the bisector tells you that it's going to be at the midpoint. Is essentially the point that is going to cross that line is going to be at the midpoint between P and Q, and therefore you're essentially bisecting the line in half. So you're like cutting the line in half. So this side and this side will equal each other. So to do that we need to do two things. First of all, let's find the gradient, so find the perpendicular part. So to find the gradient m, so we say m1 is equal to change in y over change in x, which is equal to y2 minus y1 over x2 minus x1. We'll take p as 0.1, so x1, y1, and we'll take q as 0.2, x2, y2. So we plug this in, so it's going to be 7 minus 1 divided by 5 minus 3. So that's equal to 7 plus 1, which is 8, and 5 minus 3, which is 2. So that's equal to 4. So therefore the m2, which is the gradient of the perpendicular bisector, is equal to minus 1 over m1, which is equal to minus 1 over 4. So therefore we found the first one, which is the gradient of our new line that we want to find. And the next point here is we want to find the midpoint between P and Q. To find the midpoint, we're going to do x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So plugging our numbers in the formula, it's 3 plus 5 divided by 2, and minus 1 plus 7 divided by 2. So 3 plus 5 is 8, divided by 2 is 4, minus 1 plus 7 is 6, divided by 2 is 3. So the midpoint is 4 and 3. So now we've got the gradient of that line, and now we know one of the points that line is going to cross. We're going to plug it into our equation. So we know y is equal to mx plus c. We know that y is equal to 3, x is equal to 4, and our gradient is equal to minus 1 over 4. So plugging that in, we get 3 is equal to minus 1 over 4 times 4 plus c. So 3 is equal to 4 divided by 4 is over 1, so it's minus 1 plus c, so c is equal to 4. And then we just plug it in to show our terms, so y is equal to minus 1 over 4x plus 4. So essentially a is minus a quarter, and b is equal to 4. And that gives your answer for question 16. Question 17, we have VABCD is a rectangular base pyramid where AB is 12 centimeters, BC is 10, and VC equals 14. The base ABCD is horizontal and the vertex V is directly above X at the center of the base. Work out the height of the pyramid. So essentially what we're interested in is we're interested in this Vx. Now Vx is goes towards the middle of the pyramid. Here what we want to do is we want to essentially make a triangle and use Pythagoras to find it. Now one way we could do this is we can make a right angle triangle here between, so the right angle is going to be between x and c, because this is a vertical line and then that joins to a horizontal line, so they're 90 degrees between each other. Okay, vertical and horizontal are always 90 degrees. So therefore we get this triangle that we can draw, which is as follows. We have V at the top, X at the bottom, and then C at the side. So that's what the triangle looks like, and we know that this is 14. Now we want to find this one, call this H, but we don't know X to C. So what we can do though is to find x to c, we can see that there's another triangle we can use. And we know that x to c forms part of a bigger line, which is a to c. And this also forms a right angle triangle between a to c, c to b, and a to b. Now we know that this is a right angle because it's a rectangular base pyramid, which means that it's a rectangle at the bottom, so all the sides at the bottom are 90 degrees. So here we have a second triangle, which is as follows. A, B, and C. So from here we want to find what our A to C is. So it's going to be 12, 10, and we know that our x point is actually halfway along, but we're going to find all of A to C first because we can use Pythagoras. So to find A to C is equal to the square root of 12 squared plus 10 squared. Again, this is from Pythagoras' equation. So A, B, C, A squared equals B squared plus C squared. Here I've just square rooted it straight away, plugging our numbers in. If we plug this directly in the calculator, 12 squared plus 10 squared is equal to 2 root 61, or the square root of 244. From here, we want to find xc. Now, xc is halfway, so it's halfway between A and C, and we know that because in the question it tells us that it's at the centre of the base, so it's exactly halfway in our rectangle, and when we do a line that goes across from one end of the rectangle to the other, x is halfway across that line. So here we know that xc is equal to 2 root 61 divided by 2, ac divided by 2. So that gives you an answer of root 61. From here, we can then plug that back into our original triangle. Remember, our goal here is to find v to x, to find the sides on the VCXV triangle. So here, we're going to plug in here, and we know that that must be root 61. And then from there, we're going to use Pythagoras again to find what our height is. To do that, we're going to say that 14 squared equals root 61 all squared plus h squared. So h is equal to the square root of 41 squared minus root 61 squared. Plugging that into our calculator, we get an answer of h is equal to 11.62 centimeters. And that is your final answer. 11.62 or 11.6 would be fine as well. Centimeters, either one is fine for your answer. The next thing we've got then is calculate the angle between VC and the plane ABCD. So the plane ABCD is the horizontal plane, so it's the flat base here, so horizontal base, and VC is this side here. So essentially we're trying to find this angle here. Remember the line XC or A to C is running along the horizontal plane, so it's this angle here. We'll call it Y. And if we look, we've already drawn a triangle that represents this. So here we can say that this is Y here. And from here we can use SOHCAHTOA using either one, any of these sides that we found. H equals 11.62, 14 or root 61. It doesn't matter which one you pick. Here for more completeness, I'm going to use cosine y is equal to adjacent. So remember that this is opposite, this is adjacent, and this is hypotenuse. So cos y is equal to adjacent over hypotenuse, which is equal to root 61 over 14. And here we're going to take inverse cos of both sides, so it's inverse cos of root 61 over 14 is equal to y. Plugging that into our equation, we get root 61 divided by 14, and that gives us an angle of 56.09 degrees, which we could say is equivalent to 56.1 degrees. And that gives your answer for 17B. The next one we got is calculate the angle between the planes VBC and ABCD. So first of all, we are interested in the plane VBC. So VBC is our angle here. So VBC is this triangle here that runs down, and that is the plane VBC, and we're interested in this between this and the one ABCD. So to do that, we need to make a triangle, and to do that, well, yes, so we can't use we need to essentially make a point on our on this sort of triangle here. So we're going to, because we can't use, so currently the angle between VC is going off an angle, we can't use that to lose on our plane. So here we're going to pick a point on the plane here so that we can then generate a triangle which we can then use to find our point. So here what we're going to do is we're going to make a triangle that is between V to the midpoint between BC, so we call that M, and then we're going to make another triangle to X, and then to X to V. So here we get a new right angle triangle, and this right angle triangle here is we're going to then use to find what our values are. So here, if we draw this triangle out on here so we can still view it, so we know that this is halfway between this one, but we're not going to use essentially any of these values here. But what we do know is that the X is halfway in our rectangle, so X to M must be half of A to B, so therefore it's going to be 6 on our side. So this is going to be 6. Again, our question is looking to find the angle between the planes VBC and ABCD. So here we're going to use our angle here is what we're interested in. So it's going to be this angle here that we're trying to find between, remember it's between the triangle itself and the horizontal plane, which is why we've done this point M, so that we can then draw a nice right angle triangle with the base being the horizontal. And then we can also find the height as well. So here it gives us our angle, and we also know the height of our triangle is 11.6. And we're interested in our one, which is going to be, let's call it Z. So here we're going to use tan. So tan X is equal to opposite, which is 11.6, divided by adjacent, which is 6. Remember, this is opposite, this is adjacent, and this is our hypotenuse. Again, this is not necessarily going to be 14. We don't know this height that is going to M. Hence why we redraw it, is we're finding a different essentially plane at that point. So here it's tan X equals 11.6 over 6. So therefore X is equal to the inverse of tan of 11.6 over 6. And plugging into our calculator, we get the answer of 62.65. And which we can simplify to 62.7 degrees. So again, if you're trying to find the plane, maybe like in these situations here with the triangles, make a midpoint between the side at the bottom, so between B and C, and draw a similar right angle triangle, what you've done with all the other points here. By making sure that it's the midpoint and not any of B and C, you're ensuring that you're only considering that plane. Remember, B and C have lines that are just bordering on the plane, but we're not actually on the plane itself. So you want to make sure that you're finding the angle between the whole plane. So that gives us our answer for question 17C. The next question we have is question 18, which is cos squared equals 0.8 for the angle between 0 and 360. So the first thing we can do here is that we can square root to get rid of our cos. So it becomes cos x equals to plus or minus the square root of 0.8. This is a critical move to remember the plus or minus part here. And then from here, we essentially end up with two separate solutions. Cos inverse of the square root of 0.8 and we equals x, and we also have a second answer, which is the cos inverse of minus root 0.8 is equal to x. If we look at a cosine graph, just to give you some indication of where we're looking for, so here we are going to, cosine graph starts at 1 at 0 degrees and looks like this over the period of 360, crossing the axis at 90 degrees, and 270 degrees. So if we draw a line of roughly where these points are, we are looking for 2 and then another 2 points here. So it's going to be in total, we're looking for 4 points. 1, 2, 3 and 4. So to find those, to find the first point, we'll focus on the cos inverse of root 0.8. So to find that, we're going to just plug that straight into your calculator, and you find a first value cos root 0.8, a first value of 26, so x is equal to 26.565 degrees. I'm going to call this x1 because that's going to find our value here, 26.65 degrees. Now here, what we want to do is we want to find the second value, and the way that we can find the second value, there are several ways. There's the CAS method, etc. But the way that I prefer to use is to use a formula, which is 360 degrees minus the initial angle. And the way that we work that out is that the whole cosine graph is symmetric, so 26.6565 degrees. So here we're going to start, if we start at the top of the hill and move down to where root 0.8 is, we have travelled in x 26.565 degrees. Now if we start from the other side of, let's say, our peak, so our hill essentially, and we were to travel down to root 0, so if we were to travel down to where our root 0.8 is, then we would travel the same distance in x but the other direction from 360. So here this distance is going to be 360 minus 26.565 degrees. So we're going to use the same idea here to find our second value. Again, you don't need to show this in the exam, you can just write 360 minus 26.565, and we put that into the calculator and we get an answer equal to 333.435 degrees. So that finds us our first two values, and then the second value we're going to do exactly the same. We're going to do, so plug that directly into the calculator, so inverse cos of minus root 0.8 is equal to 153.435 degrees. And then in the same step that we have done here, we can do 360, so x2 is equal to 360 minus 153.435, which gives us an answer of 206.565 degrees. Again, the same concept here. If you start from the top of the hill and you travel all the way down to where it first reaches minus root 0.8, then you have travelled 153 degrees, 0.435. So then we use the same idea here. You start from 360 and you come down the hill. It's symmetrical. So this gap here is going to be 360 minus 153.435. Oh, it should be a gap away of 360. So therefore, we found our four values, so we can write it all as a nice answer. I suppose x is equal to 26.6 degrees, 153.4 degrees, 206.6 degrees, and 333.4 degrees. But that is your answer for this question, question 18. The last question of this video is going to be y is equal to x to the power 4 times 2x plus 5. Work out the rate of change of y with respect to x when x is equal to 2. So here the first key thing I look at is the rate of change. That tells you immediately that you're going to differentiate. Okay, why are we differentiating? Well, it wants the rate of change of y with respect to x. So it wants the change in y over the change in x, so dy dx. So first of all, to differentiate this, we want to expand our terms. So it's x to the power 4 times 2x is 2x to the power 5, and x to the power 4 times 5 is 5x to the power 4. From here we're going to differentiate, so dy dx. Remember the general rule for differentiating, if it's ax to the power n goes to anx to the power n minus 1. So you multiply by the old power, so in this case it's going to be 5 times 2 is 10, and then you're going to reduce that power by 1, so it becomes x to the power 4, and the same here, 5 times 4 is 20, so multiply by the old power, then reduce that power by 1 to get 20x cubed. So now we've got our differential, we want to then substitute in our value. So it says when x is equal to 2, so we say that dy dx is equal to 10 times 2 to the power 4 plus 20, 2 to the power 3. From here, we just plug that directly into our calculator and we get an answer of 320. So your rate of change here is just going to be 320. Okay, that's the end of this video. If you have any further questions, please let me know.